Hello and welcome to today's webinar on the state of API security 2026. If you're here today, no doubt you've already had a chance to perhaps read our report. Today's session will go into look at all the API vulnerabilities and exploits over the past 2 years with a look forward into 2026 and what that means. Our speakers today, Anthony Lonergan, who leads product marketing here and is also the editor of the popular API security newsletter, which we have used as a kind of the source for a lot of the stories that have fed into this report over the last 2 years. So he's compiled a report that we're presenting today, and a lot of the findings we hope you find insightful and helpful. And supporting him today is Heshaam Attar. Heshaam is Senior Solution Engineer with 42Crunch. And after Anthony's recorded session, he will be giving you a live demonstration where he walks through some of the key findings of the report and shows you how, with the 42Crunch API security platform, these vulnerabilities can be identified and remediated before ever reaching production. So be sure to hang on to see the learnings in action after you've seen Anthony's piece from Heshaam. So first up, we're going to play the insights from the report as prepared and compiled by Anthony.
So in this session, we'd like to share information about some of the common causes of API breaches and API vulnerabilities that reach production sites. This is based on research that we've done over the last 2 years and that we've included in a recent report on the state of API security. So I'll briefly talk about some of the research and the data that went into the report. I'll describe the different ways we categorize the vulnerabilities, both for security teams and also development teams. And then I'll pick out just some of the key findings from the report, and we can talk about those in a little bit more detail. In terms of the research that we do, we provide this newsletter, apisecurity.io. This is a resource that we put out every 2 weeks where we summarize all of the latest news about API vulnerabilities, API breaches that have been reported in the industry. Now, what I find oftentimes with these types of industry reports that companies put out is that the stats are pulled from their own platforms and their own tools. So it can be a little bit narrow and biased with the information in some of these reports. So what we've done with the newsletter and with this report is different. We've gone out into the wider industry and we track about 90 to 100 different sources of information about API breaches and API vulnerabilities that were discovered. So, for example, we're tracking security advisories, bug bounty programs. We look at a lot of reports from independent researchers. So these are really experts in API security and in discovering API vulnerabilities. They use a lot of the same tools and methodologies that hackers will use to look at your applications and your APIs and discover and exploit vulnerabilities. We also look at security firms who do penetration testing and red teaming. So on the right, you can see a partial list of just some of the sources that we track. And so this gives us a broad picture of the real world cases of API vulnerabilities that are reaching production and the causes of those vulnerabilities. So we've been tracking these sources for the last 2 years. We've compiled a list of all of the cases relevant to APIs. We only include cases that are verified as real world cases. We're not looking at, hypotheticals. It's all based on valid real world cases. And we only include cases where there's enough information so that we can understand not just the vulnerability, but the root cause. So, what was the mistake made in the API development that led to that vulnerability? That's really what we're after. So we've compiled a list of about 200 cases over the last 2 years. You can see on the right here, just again, a partial list of some of the companies and projects that are included. If you're tracking the newsletter, you'll be familiar with a lot of these cases. We've gone into some detail for each of these, and we didn't narrow it to a specific industry or a specific technology. You can see on the left the distribution of the cases in terms of industry and the different platforms where these API vulnerabilities were discovered. And what we did notice is that it's a common trend. It's the same API vulnerabilities that keep coming up again and again. It's the same mistakes that are made in API development that leads to those vulnerabilities. It didn't matter if it was, a small open source project with a handful of developers or a major enterprise with hundreds or thousands of experienced developers. Even in some cases, we looked at API companies, teams who specialize in API security, who themselves make the same mistakes in their API development. So it's common in cases that come up again and again. It's the same issues when these industry experts, these researchers, when they go out and they look at companies and look at their APIs, it's the same vulnerabilities that keep cropping up again and again. So what we're looking for in the report is to extract information, trends, the common causes of these vulnerabilities, and how you can prevent these vulnerabilities from getting into your production sites by improving your API development. All right, so that's the source of the data. Next, I want to look and talk briefly about how we categorize all of the data that we compiled. So I guess the most obvious way to compile vulnerabilities is through the OWASP categorization. So when we take all of the cases that we looked at and sort of map them into OWASP, how this distribution looks like. So starting from the top right here, this is the OWASP API list 1, 2, 3, 4, 5. Let's just remind ourselves of what those are. So you can see the most frequent case we covered, the one that's found most frequently by these researchers and in bug bounty programs, etc., is broken authentication. You can see actually the top 4 most frequent cases, most frequent vulnerabilities. You can see it's API 1, 2, 3, and 5. So there's a correlation here between what researchers find when they go and look for vulnerabilities and the OWASP ranking, the OWASP API top 10 ranking. So it's a good correlation there. Now, obviously, the OWASP top 10 list for APIs, it's not comprehensive. It's not going to cover every single case. So for full coverage of all of the cases that we reported on, we had to go outside of that list. So, for example, you still find lots of cases where APIs are vulnerable to SQL injection. That's not in the latest API list, but it is included in the 2019 list. So we've included that. And then another one was path traversal attacks. A lot of APIs deal with files, and we're vulnerable to path traversal attacks. So I don't think there's an entry for that in any of the OWASP lists, but there is a reference to it under broken access control, so on the more general OWASP list. So we've included that as well. So this type of categorization is interesting. For security teams, you'll often see, testing tools, DAS tools will kind of focus on presenting results this way. We also do that, but then we also want to present it for development teams. It's very difficult for a developer to take this information and sort of apply it on a day-to-day basis, right? And when they're actually developing the APIs. So instead of focusing on the vulnerabilities, we want also to present this data in terms of where the mistakes were made, like where in the API development the mistake was made that caused that vulnerability. So to understand where the mistakes are made in API development, it's good to remember what actually an API is. It's not like a mini web application. It's not even a microservice, right? An API, it's an interface. It's the I in API. So it's an interface or boundary that a developer is coding, where you're exposing a service or a function, usually from a trusted domain to some untrusted domain. And then the other thing that makes an API is that it tends to be data rich. You have a lot of business level data and metadata that's crossing that boundary, right, coming in and going out. And so if you're a secure API developer, your main job is to make sure you're coding that in a secure way. And there's some key areas of responsibility that you have to get right. Authentication. Again, if it's not a public service, you need to make sure you're authenticating the requests. Authorization, fine-grained authorization. It's not enough just to say what are the permissions of the user. You have to check to make sure, is this user authorized to access this particular resource in this particular way? And that's, again, the responsibility usually of the developer. Input validation, again, so important that you implement your interface or your boundary to make sure only valid data crosses that boundary. So you don't need developers to be security experts, acting like firewalls, looking for SQL injection patterns. But what developers are really good at is understanding, for this service, this is the data I'm expecting, that we expect to come in, right? If it's account IDs or healthcare data or banking data, developers know, the schemas, the formats, etc. And so validating that input and failing fast if it's not right, a real key task for developers. And then likewise on the data going back out, making sure it's valid and, you're preventing any data loss. Another task, configuration security. So aside from the custom code that you're developing, just making sure that any of the configuration defaults, things like libraries, frameworks, are properly configured and are secure by default, that you're not exposing endpoints through an exposed library, or TLS is enabled, these types of configuration settings. And then finally, inventory management. Again, a key task for developer, because the developers are the ones poking holes in your system, right? They're exposing APIs and endpoints. So it's the primary responsibility of a developer to keep track of those and make sure there's kind of shared visibility on what are our APIs and our endpoints that are being published. So if these are the areas of responsibility for secure API development, mistakes made in these areas are what leads to vulnerabilities. So when we went back and did the analysis of all of the cases that we found, what we found is that these are the areas where mistakes are being made that need to be addressed in order to avoid vulnerabilities getting into production. All right, so that's the different ways that we categorize the data in the report. And now I'm going to drill down into some specific findings. So let's look first of all, the category that had the most mistakes, we'll say, was again related to input validation. And then these are all of the different types of vulnerabilities that were found related to malicious input, whereby the API wasn't properly validating the input that's coming across that boundary, and so it allowed attack patterns to get in. So a lot of times the attacks, they're not targeting the API directly. So for example, with SQL injection, you're targeting the point where the code is making a query to a database. Okay, and you still need to follow best practices, the OWASP recommend for using stored procedures, or different ways to handle your SQL queries, NoSQL queries in a secure way. But as an API developer who's responsible for coding that interface, your responsibility is the input validation, making sure only valid data comes across that boundary. Because by doing that, you can eliminate or reduce the risk of a whole classes of different vulnerabilities. And as I said, these were the cases, these were the vulnerabilities that were most frequently reported by researchers when they went looking for vulnerabilities in APIs. So we saw a number of cases in the newsletter we reported, like Trellix. This is a cybersecurity company. They build security platforms, and those platforms were found to be vulnerable to path traversal attacks through the platform APIs. In another case, we covered the Formula One website, where researchers were able to do a mass assignment on an API. So that's where you're sending properties through in the API request that the API should block. They shouldn't allow those through. So again, that lack of input validation can expose your APIs and your backend systems in all these different ways. And so input validation, it's a really important task to encourage with your developers. So in addition to looking at all of the different types of vulnerabilities, we also mapped back to, we did the research and looked at where the malicious data actually comes in on the API request. And so we can see then that the majority of the malicious patterns that come through, they come in on the request body or the query parameter of the API. So if you have limited time, let's say limited resources, but you want to engage your developers and help them to build more secure APIs, this would be a good place to start. Encourage your developers to do schema validation rigorously on the requests and the parameters, request data and parameters for those APIs. So that can go a long way to preventing these types of vulnerabilities. All right, so the second category I want to cover that came up a lot, it's authentication bugs and mistakes. So we saw a number of different types of authentication errors by developers. The most prominent one by far was missing authentication. That's where you have API endpoints that should enforce authentication, but didn't. It was just completely missing. Another one, weak authentication. So you have authentication in place, but it has weaknesses. So things like the access token is not properly validated, so you can spoof it and gain unauthorized access. And then authentication bypass. That's another one we cover in the report. We saw trends where developers, they use certain patterns to sort of skip authentication for like public APIs. And that's really easy to exploit and then gain access to private APIs in ways to bypass authentication. So again, we cover all of this in more detail in the report, but I think certainly missing authentication is one to watch, because whereas the input validation was the category that we saw the most cases of, just an individual type of vulnerability, missing authentication was the number one. It was the most common one that researchers found for all of the cases we covered in 2025. So we have 17% of all of the vulnerabilities. So it's really prevalent. So again, making sure that you distinguish between which of your APIs expose public versus private services, and then making sure the authentication is enforced on those private services is really important. So again, an example of this we saw with in the UK's National Health Service. There was an API that didn't enforce authentication, and it gave access to patient data records. So it meant anybody without authentication could send an API request in and pull out records. And again, we saw this across many different industries, so one to watch. And then the final case was authorization. Again, we see this come up a lot. BOLA in particular, so that's the number one in the OWASP API top 10 lists, broken object level authorization. That's where, for example, here's a case where a researcher found a BOLA vulnerability in the India's goods and services tax portal. So what it meant was somebody could log into the tax portal, and then the portal would send an API request to retrieve their tax information using a receipt ID. And what the researchers found, if they just changed the receipt ID to somebody else's tax receipts, then the API, it doesn't check that this particular user has access or is authorized to access this tax receipt. So it returns the tax information of other companies and other individuals. And this is really, really, again, prevalent. We saw this in everything from IoT devices. We saw it in McDonald's delivery service, online delivery service. So this, again, it's a go-to tactic now, BOLA, of a lot of hackers. Anyone who's any kind of sophistication with API hacking, this is a go-to test that they will try to try and access, your customer's private information. So again, really, really important to watch out for. It's really the responsibility of developers to implement these controls. So again, raising awareness, doing thorough testing specifically for BOLA type vulnerabilities, that's really important. And BIFLA also, so that's function level authorization. A lot of those cases are basically broken role-based access control, where you have like administrator level services or partner services that the API doesn't enforce the right authentication. So regular users were able to access privileged services or functionality. So again, very prevalent and one to watch out for. Okay, so that was just some of the key findings. And again, we go through all of it in more detail in the report. Just a couple of other points, some of the trends that we saw from reviewing this data. And one was this concept of a back-end miscommunication between front-end and back-end teams. And we refer to it as client-side security mindset. And the best way to describe it is to contrast it with an API security mindset. So for example, if you're doing development, and open banking is a good example of this, where your team is building APIs that are intended to be consumed directly by some unknown people, third-party developers outside your company. So when you have unknown entities coming in, accessing your APIs directly, there's sort of a sense that you have to get the API security right? We need to make sure we're authenticating because we don't know who these people are, get authorization right, input validation, all of that stuff. So that's an API security mindset. You're focused on securing the individual API, which is the way things should be done. But what we noticed looking through some of these cases, if you're developing your APIs to be used by your own applications. So what I mean by that is you have a back-end team building your APIs and a front-end team who build your mobile apps, your websites, your SaaS platforms, who use those APIs. So what we noticed, there seems to be a mindset where the API developers say, well, we don't need to do the security because the client side will handle it. So for example, the API team might think, okay, all of our users have to log in on the SaaS platform before there's any API traffic anyway. So we know all of the API requests, the users already authenticated, so we don't have to authenticate again. Or another example might be the API developer will just say, I'm going to return all of the record, the entire user record, all of the data to the mobile app, and I'll let the mobile app, the front-end team, decide what to display to the user, what data is sensitive and what's not sensitive. So it basically means you're offloading the security checks to the front end. But what it means, of course, is that, hackers, or in a lot of cases, researchers, they can so easily bypass whatever your client, your client-side security. So if you're doing filtering, data filtering in the mobile app, or you're only doing authorization checks in the SaaS platform, the hacker can just go directly to your API. They will absolutely get access to the API traffic and figure out how to talk directly to the API. And that means they're now talking to an API that has no authentication, no authorization, and that's leaking a ton of sensitive data. So it's a really, we found this in about 20% of all of the cases we covered, whereby the front end had the security, had, we'll say, authentication enforced in the mobile app. But when you went to the API, there was it's not checking for access tokens or sessions or anything like that. A good example of it was an Intel website. So you can see here, for example, one of the cases that was really prevalent was data loss prevention. So what I mean here is that the API developer was not doing any data loss prevention. They weren't filtering the data. They were just sending a lot of data back to the client and letting the client decide what to display. And you saw an example of that with an Intel website. So the website displayed, it was an employee website. And the website itself displayed very basic information about the employee. But if you look at the API traffic, there was a ton of really, really sensitive information in the API traffic. So you have this mindset to let the client figure it out. And again, it's really, really one to watch. So we spend a lot of time at 42 Crunch. We work with teams to try to help them with this, because it's a sign of miscommunication between your front end team and your back end team. It's a sign that your security team is not involved and not able to enforce security policies at scale to make sure that there's consistency in that your API teams are doing the proper security at the API level. So that's something we do a lot of work with our customers to make sure they get right and they can automate that. All right, and the very final point then I want to make is just looking ahead into 2026 and what it means to start hooking up your APIs to AI agents and LLMs. So again, going back to the data and all of these cases that we found, it's the same vulnerabilities. They're everywhere. The same API vulnerabilities keep coming up again and again. If you have APIs, you're doing API development, chances are your developers are making similar mistakes and you have similar vulnerabilities in your APIs that are in production. Now, one of the things we've found is that a lot of those API vulnerabilities were in production for a long time, months and years in some cases. And it was only when you had these researchers go and examine these companies and look at their applications and then get into their traffic and play around and discover these vulnerabilities. It's only then that they were noticed. And it's really something worth thinking about when it comes to AI agents and LLMs. So if you think, for example, any of the traditional applications or clients like mobile apps, websites that use your APIs today, they're pre-programmed to use your APIs in a specific way, right? Again, using a very basic example. So the clients will call your API and then they're programmed to expect certain data back, for example, right? So if your API suddenly starts leaking a ton of extra information, and again, we've seen so many cases of this where this happens, maybe a regression or a configuration change. If your API starts leaking data, the traditional client app is not going to pick up on all that extra information because it's just programmed to use the data that it's expecting. So all that extra data will be ignored. And your end customers probably won't see it. Again, unless you're lucky and a hacker starts poking around. And so it's no wonder that you could have these vulnerabilities latent in your production sites and not know about it. Okay, now, but this is where AI agents and LLMs are different, because they're not pre-programmed necessarily to use your APIs in a certain way. They learn how to use your API. They will monitor the traffic coming back from your API, and they'll use that full context to learn how to interact with your API. So if your API starts leaking extra data, the AI agent and LLM will pick that up immediately and it will use it. It will either figure out new ways to use or misuse your services, or it can actually prompt it back to the user and say, hey, here's all this extra information I found, and you can access this without authorization. So when you hook up an AI agent or an LLM to your API endpoints, it's like putting researchers on your APIs and letting them figure out all of the vulnerabilities. So all of the vulnerabilities that you have going into your production sites today are going to be exposed automatically by AI agents. And that's the real risk to be aware of. So again, going back to this list of all of these companies that had these common API vulnerabilities, the goal again is to prevent those vulnerabilities getting into production in the first place, because now that you have these AI agents and LLMs, they're going to very quickly discover and shine a light and expose and potentially exploit these vulnerabilities if you have them in your production sites. So again, it raises the importance of improving your API development cycles. Again, using the information that we provide in this report to show or to understand what are the root causes, what are the areas in your API development cycles that you can improve to reduce the number of vulnerabilities that are getting in the first place. And again, we use all of this information as well in our tools, the products, the solutions that we provide our customers. So next, I'm going to pass it back to my colleague who can run through some examples and show you some of those 42 Crunch solutions.
That's great. Thanks, Anthony. We're now going to hand over to Heshaam and run you through some demos which go in intensively and look at some of the key insights that have come from the report and show how today, using 42 Crunch, you could actually identify these problems and remediate them. Heshaam, if you want to take over. Thanks.
Awesome. So thanks, Anthony. Appreciate that. So today here, just kind of wrap this up, what we want to kind of cover is show you how 42 Crunch can detect and fix those top API vulnerabilities. So Anthony did a great job of categorizing those into various different categories, like you see on the screen here. If you look at these, obviously the top three, like over 75% of the cases have to do with input validation, authorization, authentication, right? So we're going to take a look at those three in more detail and really show you how to identify those vulnerabilities and remediate them in your system, okay? So we'll take a look at input validation or broken input validation here. So we'll be able to detect this through our contract testing and schema validation through our scanner. So again, this is where the contract becomes so important, the open API specification of that API, because it's sort of bridging that gap between those front-end, back-end teams to understand what data should this API consume versus what should it produce, right? So we're going to look at broken input validation. We'll also look at missing authentication. So again, over half the cases of authentication issues had to do with missing authentication. So we're going to cover that step here. And that's going to be, again, through the contract, because that defines those security schemes. And our scanner will then validate those security schemes. So we'll look at something called drift scan, which is more of a production scanner monitoring tool. And then lastly, we'll look at broken API authorization. So, of all the authorization issues, Ebola was one of the biggest ones. So we'll show you how to tackle that, with our API security scan as well. So really the first one I want to start with here is actually missing authentication. And I'm going to show you a new concept we have called drift scan. Okay, so I'm going to flip over here to this is a 42 Crunch SaaS platform. I'm taking a look at an API in here that we've pulled in and run various analysis reports on. So you see here, we have some sort of scoring here of the quality of the API, which is doing very well, 100 out of 100. We've also run various other reports here, like API scan and a drift scan. And you'll notice if I hover over this API, we do indeed have some drift issues. So that means this API that's running in production, our drift scan has picked up discrepancies in that actual implementation where it's not conforming to the contract. So we can go ahead and quickly first take a look at that drift scan issue. So I'll just flip over to my API scan reports here. I can go ahead and take a look at my drift scan report. This was ran just a few hours ago. And again, this is a production monitoring tool. So your API is running in production or your third-party APIs. This is a scanner that monitors those running APIs to ensure while they're in production that they don't drift from the contract. Part of that drift, as you see here, there's API drift detected. Part of that drift will include things like missing authentication. So if I kind of sort the issues here by the highest severity, you'll see the very top two issues here have to do with something called partial security accepted, or really this is missing authentication or broken authentication. So this is actually our scanner testing this production API to see, hey, can I actually access these endpoints without the proper security requirements or the proper authentication? So in this case, the scanner sends it without the missing, here in this case, a bearer token requirement. And then the API actually accepts the request successfully, even though it doesn't have the proper authentication, right? So this is the beauty of the drift scan is you can catch this on your production APIs in real time as this is happening. So here we've kind of determined that we found an OWASP issue on that API, and we can actually read more about those issues here, based on the OWASP API top 10. This is, of course, broken authentication. And as I mentioned, over half the cases of broken authentication in the report had to do with just missing authentication or unprotected APIs. maybe they were internal or they thought they should be internal, right? So that's a quick example of how we can very effectively pick up issues like missing authentication on your APIs. And we can even do it on that production API, as I showed you, via that drift scan. So that's super, super useful. But then if we were really going to take a look at how are developers using this to fix their APIs, they actually want to look at pre-production, right? So we're not necessarily going to always want to look at what's happening in production, but we also want to test what's happening before the API gets to production. And so that's where our standard conformance scan comes in play here. So this is another report, which was also executed. And I just want to mention this runs automatically in the CI/CD pipeline. So this actually ran from a GitHub Actions job here. But essentially, this is running every single time there's a change to this API pre-production. The developer makes some change, then the API is automatically scanned and tested via this API scan here. So this will actually pick up, all those OWASP API top 10 issues, and it will fully test the pre-production API to ensure that it's not vulnerable to those issues. So what I want to show you in this report is one of our examples, broken input validation. So how do we actually test and validate the API isn't susceptible to input abuses, right? And so here, what we can do is simply filter this report to see, here are all the various issues that were found, the tests that were run. But I'll simply just filter this on, let's say, OWASP issues. And I happen to know that issue number 8 is an injection issue here. So this would be like an input validation issue. And so we can see how many of those did the scanner actually find on this API. So what the scanner is doing here is it's consuming that API contract, the OpenAPI spec, and it's really generating very specific fuzzing payloads to manipulate all different types of elements of the request. So it's manipulating anything from query parameters, path parameters, post body parameters, et cetera, really anything in the request body as well, and in the response. And it's basically saying, hey, can I abuse this API in a way? Can I fuzz those various elements of the request in a way that would prove that there's an injection vulnerability on this API? So for example, this is an API that handles vehicle information, automotive data. So it consumes vehicle VIN numbers. And so a VIN number has a specific format, right? It's got a minimum boundary, a maximum boundary, a specific pattern, capital letters, numbers, etc. And so our scanner is going to intentionally abuse those parameters of those elements to see, is this API susceptible to injection? And again, we can prove that the API is susceptible based on its response, right? So if the API is producing a successful response, it's actually consuming that invalid VIN number and it's returning it back to the client here. So our scanner is going to immediately pick up that, hey, this API is not properly validating those inputs. And as a result, it can also be susceptible to all sorts of various injection attacks, right? So your SQL injections, NoSQL, command injection, et cetera, right? So this style of testing, again, is centered around that open API contract in order to gain the context of the API to properly send these types of tests. So we can obviously detect those input validation requests. What I also want to show you here is how do we detect the broken API authorization requests as well, right? So that's that third category, which has to do with authorization, accessing resources that you shouldn't be able to access on the API. So we can do the same thing in this report, and I can simply filter here on API 1. So that's broken object level authorization, or BOLA. And again, we can see this API does have those BOLA issues that have been discovered on various endpoints in pre-production. And BOLA, again, was over half of the issues in authorization had to do with BOLA. So here in my various endpoints of this API, I can delete vehicles, get vehicles, update vehicles. In all cases, this API is suffering from BOLA vulnerabilities or authorization vulnerabilities, where an invalid user, an unauthorized user via their credential, that bearer token credential, is able to access a resource, in this case, a vehicle. So they're fetching some vehicle via a UUID number. And these are the types of parameters that can be enumerated through and abused, right? So essentially this user here doesn't have access to that resource. However, the API is allowing the user access once again here with a 200, right? So again, this is a BOLA vulnerability or authorization style vulnerability, is allowing users to access, maybe delete resources, edit resources that they should not be able to, right? So those types of issues that I mentioned, right? Input validation, authorization, missing authentication. Very easy to detect those with our scanners. We can detect those both in production with that drift scan and pre-production with our full conformance scan. But really where it becomes powerful is enabling developers to have access to that data so that they can ultimately fix those issues, at the source, in the source control, right? So what I want to flip over to then is how can a developer actually tackle these issues? What would they see from their perspective, in their own environments where they work? So typically a developer is going to be working in something like a VS Code, IntelliJ, or Eclipse IDE. And so right here, I've opened up my VS Code IDE. So as a developer, essentially what I've done is I've pulled the code base here. So I have the API code locally. And all I'm simply going to do is use the 42Crunch plugin here to scan that API. So here I'm presented with, all the various different endpoints of this API. So remember, we had input validation issues, we had missing authentication, we had broken authorization as well, right? So all I have to do is pick one of those endpoints that had an issue and simply click on the scan button here. So now the same sort of scan logic that was running that I showed you in that main report in the platform, that same logic runs here in the developer environment. And it's very, very fast and efficient. It essentially takes that contract and generates all those unique fuzzing test cases on this API. And here you can see we executed 19 tests just on this single endpoint, right? So the developer can quickly test that endpoint to see, hey, do I have any issues or do I have very critical issues? So if I see here on my very critical high issues, I do have a few. And one of those issues, as we looked at earlier, is an authorization issue. So there is a BOLA issue on this API, as we saw just a little bit earlier. Now the developer can see that issue as well right in their IDE. And they can actually see, okay, what is the operation that this is correlated to? They can click on this little pointer here, and it takes them right to the contract, right to the OpenAPI spec, where we can now fully see, what's defined for this API. What are those property constraints? What are those responses? Everything, make sure it's kind of fully defined. And we have tooling to kind of help the developer improve this contract. But ultimately, right, we want to focus on the issue here. And we've found that this API is vulnerable to BOLA because it's returning a 200 response to an invalid user with their credential here, this bearer token. So simply as a developer, I can very quickly fix those issues. Just kind of open up the source code here. So we have our app, really just this one file I'm going to open. And not to get super technical here, but this is essentially my controller for the app that allows me to access those API endpoints. And you can see in the comments here, there is a BOLA vulnerability, as you can see. So luckily for me, I've already put in a solution here. So I'm simply going to uncomment this code. And all this code does is it checks that the user who's trying to get this vehicle, this object, is the right user. It's just that they are the correct user who owns that vehicle, essentially, right? So it's just a simple check that I put in, and I saved the check there. So now all I'm going to do is rerun the analysis. So as a developer, this is typically what a developer would do is they would test the API, fix the code, rerun the tests. So I'm rerunning the tests now so I can actually validate that the fix was put in place. So again, we're running the tests here, and we want to just ensure that the issue that we addressed is no longer present in the report. So here you see we only have 2 critical high issues in the top right. So it looks like that issue did disappear. So I'll just go to the total number of issues here. And as I scroll down, I just want to show you the BOLA issue is now passed. So you'll see it will not necessarily disappear from the report, but it'll show as passed. So it's no longer a critical item because the developer has fixed that issue. And now the API is responding appropriately with a 403 rejection of that request versus accepting it. And that's essentially how the developer would sort of iterate through those issues that I mentioned. And then, once they're completed with all those issues, they simply just have to commit those changes back to their source control. And the beauty of that is it will, re-kick off all the validations that 42Crunch does. So if I simply say, hey, I'm going to go ahead and commit this code change and say, fix the BOLA issue, and I sync, this will go ahead and kick off the pipeline. And so now really all the reporting comes back into 42Crunch. I guess we can get into the Q&A now.
Yeah, absolutely. No, thanks very much for that. And hopefully folks found it enlightening. So I know there's a couple of questions in, if you want to have a look at some of them. I know one of the first questions there is just related to the drift scan component that you showed in one of the demos. Is that a standalone module, or is that something new? Does it come with the platform today, or is it something new that's coming? What is it?
Yeah, so the beauty of it is it's built into our existing functionality. It uses our same scan engine that our API scan uses, and it's totally separate. So you don't need to run the API scan in order to run the drift scan. They can run totally separately. The drift scan is designed to monitor your production APIs. Okay, so the ones running in production, we don't want to necessarily hit them with a full-blown scan because
Uh-huh.
it's too invasive, but we want to hit them with a drift scan, which is a little more lightweight, but we're still going to pick up a lot of those missing authentication, a lot of those issues.
Okay, thank you. And then another question said, so I guess they get the kind of scan and audit component that we showed, but the actual enforcement at runtime, is there a runtime component as well to the platform that is available?
Yes, yes. So over here on the right, there is a firewall. This is runtime API firewall. So this is essentially a API native. It kind of sits with the API, but what it's doing is real-time schema enforcement. So again, as we do in 42 Crunch, we consume that API contract to do our analysis. Firewall also consumes the API contract to do its protection. It really just configures a really strict protection policies on that API based on its contract.
Okay. And again, I guess this one relates to the OWASP in general. They said they saw the Bola example, but do we cover the other OWASP API top 10 threats as well? I guess that's a pretty generic kind of question.
Absolutely, yes. We cover all the OWASP API 2019 and 2023, and really all can be filtered on in the report here. So if you were to go to the API scan report, you can actually filter on any one of those issues as well. So we give you the ability sort of just to choose OWASP issues here.
Oh, okay. Okay.
And you can see you have the 2019 as well as the 2023.
Yeah, one person asked a specific question relating to the Bola test case. Are we distinguishing between I'm not quite sure the context, but between a B2C Bola issue versus a B2B API where it might be designed to allow the fetch of all objects? Does that make
Yeah. So
context?
that would depend, right? If it's a B2B and that's allowed, then that test won't even necessarily have to be run in those cases because we know that's allowed, right? But
So,
typically from B2C, you have various users, right? And so you don't want some user to access something they shouldn't access. So yeah, it does depend on the case, but in
mhm.
most cases where we found authorization issues, over half of those were actual BOLA issues on the API.
Okay. Then there's a couple more questions. Do you have an agent for the Visual Studio IDE in addition to VS Code? So I know we have
Visual.
JetBrains, I know we have Eclipse. Maybe you know the others.
Yeah, so IntelliJ, which is JetBrains, Eclipse, VS Code, Cursor, any flavors of VS Code or JetBrains, or even any Eclipse subvariants, those will all work. Visual Studio, like Enterprise, that's different than VS Code. We don't have that yet. That's something that's kind of in the works for us.
Okay, gotcha. Yeah, so the scan in VS Code, it's in the Q&A box there, but the scan in VS Code, is it checking the JS code, brackets implementation detail, or
No,
is it looking
okay.
at go ahead.
Yeah, yeah. It's essentially looking at the Open API spec and it's crafting a request. So the scanner is just interacting with the API endpoint via requests to it. So it's crafting specific requests based on what that API has defined in its contract.
Gotcha. Okay, and last question relates to BOPLA and BFLA testing. So I don't know if we've any examples you want to just quickly jump into there just to share.
Yeah, so BFLA, that's a good one. I can even filter here if I go test type, authorization. I can see all the authorization tests, which would include also BFLA. So BFLA is very similar to BOLA. It's an operation that should only be allowed by administrators or someone with elevated privileges. And so our scanner will again send a credential that has just standard regular privileges, right? So not an admin. And we'll see, can we access the endpoint? In this case, again, we get a 200 from the endpoint, which means we can access it, which would indicate there's a vulnerability here.
Gotcha. Okay, great. And I guess, if people do want to get to see the product in more detail, we do have a link after these slides just showing you where you can download the freemium version of the tooling. But obviously, if you want to contact us directly, you can. There's another final question that coming in thick and fast around authentication, JWT security flaws. So again, I don't know if you want to have a look at that one there? Do you detect?
Yeah.
Yeah.
Yeah. So one of the things the scan can do here is it can send intentionally invalid tokens, like basically a malformed JWT token, right? So that could be an additional test case as part of these authorization tests, where hey, we have some kind of generator that generates bad tokens, and we test those out in the API. Absolutely.
Great. Okay. Thank you very much. Okay, folks. So thanks again to Anthony and to Hesh, and indeed all of you who've submitted questions. Hopefully we got to them all. So again, some just good resources for you guys to check out. If you're not following the newsletter already, recommend you go there. As I said, free tools can be accessed on the website. And in our resources section, in addition to the report that we've just published, there's a bunch of other really kind of helpful resources that walk you through the API contract testing, how it outperforms traditional DAST, and some other exposés looking in detail at API discovery and API inventory creation. So be sure to check those out. But again, thanks very much for joining today. And as I said, the report itself is available for download from the 42Crunch website. So thanks to our presenters and thanks to everybody else for joining. We'll see you soon online.